Hi, I'm Bill Geissele. I'm the owner of Abraham and Moses Survival Equipment. You might know me from the combat triggers and national match triggers that Geissele Automatics makes. But here today, I'm here to talk about a new venture that I've embarked on. And this is a knife company that I started. A couple years ago, my son Abraham, he was about 8 years old, he asked me if we could make a knife. And I said, Abraham, instead of us just making a knife, how about if we start a knife company and we can make knives together and you can learn how to do business? And he said, Dad, that's a great idea. I'd love to do it. So I called the company after him and his little brother, Moses, who at the time was about 2 years old. Moses is now 4 years old. So this company is focused right now on knives, and hopefully in the future it'll expand out into other things. And you know, as I started the company, I was down at one of my military customers, and I mentioned that I wanted to make knives. And they said to me, they're like, you know, Bill, you should talk to Lou Goodman, because Lou's a master knife maker. And I'd known Lou because at this organization, Lou was in charge of another area. I usually dealt with the guys who did sniper weapons or assault or assault rifle type stuff. And Lou was in another area, but I talked to Lou, we had talked a little bit. But when I went to talk to him about the knives, I found out that Lou was an absolute expert on knives. He's a master knife maker. He has extensive training in this. And I said to Lou, Lou, how about, what do you think about you helping me with our first knife? Because I'm not a knife maker right now, I'm learning how to be one. And he agreed to it. And he helped us to design the first knife. And this is the Lou Goodman Special Operations Combat Knife. And Lou's here with me today, and we're going to show you this knife and describe to you a little bit about it. And certainly we'll talk about Lou and his background. So Lou, just tell us about your military history.
Yeah, thanks, Bill. Yeah, a little bit about myself. I came in the Army in the late 80s, 1989. Did most of my early years in the Army Rangers. Moved on up to a unit in the United States Army Special Operations Command. Finished my last 15 and a half, 15 years or so there. Retired last year. Like Bill said, that's where I met Bill. We've been using his products for years, and you know, all great stuff. And we started talking about knives. I was working in the heavy weapons section of that.
And by heavy weapons, that means?
Belt-fed stuff, machine guns, M240s, Modus 50 cals, grenade launchers, stuff like that, Bill. Yeah. So we developed a friendship there, and we started talking about knives. And he knew I was retiring in the near future, so you know, we started talking about his idea for this company. So,
and how long have you been making knives?
This year will be about 11 years serious. You know, I started out stock removal knives from blanks, then I moved on to hand forging. So now all of my custom pieces are you know, hand forged.
And you were taught by a master knife maker, right?
I was. A lot of my early influences in those years was, you know, some of the guys from my organization, Bob Horgan. You know, we worked together for years, and he influenced me quite a bit, and I carried a lot of his knives.
So when you were in combat, you carried one of Bob's knives that he made for you?
I did, yes. Still use it quite extensively today. And then, you know, a gentleman named Ed Fowler, we started corresponding, and he's a master smith. He took me probably 20 years into the future with the forging techniques, and I had took some leave periodically and went out and learned at his ranch in Wyoming how to hand forge, and that's the aspects of, you know, a high endurance knife that we brought to this blade here.
Tell us about Bob. He was one of your teammates, right?
He was, yeah. He was just an all-around great individual, a true patriot, a true American hero, you know. And Bob is deceased now. He was killed in combat with our organization. So. Yeah, Bob, he was just one of the greatest guys, you know, and like many knife makers, he's very willing to share his knowledge of knives with anyone that would ask.
And that's what I've noticed in this industry. You know, as I talk to other knife makers, I find out they're extremely willing to share their knowledge, share what they've learned with me. If you've ever watched that show on TV, Forged in Fire, Me and my son Abraham watch it all the time. These guys are like, you know, helping each other out or offering advice to each one, even though they're in competition. It's one of the things I love about this industry.
And you'll find that across the board, just everybody, wants to share their knowledge and help each other out a lot. So, much like we do here.
Yep.
Your guys' machining experience with some of the knowledge that I brought to the table, I think it's a great blend on what we're doing here.
So what we're going to do now is we're going to let Lou talk a little bit about his knife. It's called the Goodman, right here, the Goodman Special Operations Combat Knife. And we'll go one by one and fill you in on the technical details about this guy. So Lou, I'll turn that over to you.
All right, so let's talk a little bit about the why of this knife. We've got the protective coating on it right now. We're going to tear that off here shortly and cut up a bunch of our media here. Why this design? So, many makers before me have had a lot of influence on my design features, but function is more important than form. So everything that went into this knife is about function. This is a tool to be used for certain hard use, applications, and it's a high endurance knife, and I'll tell you why. This knife is basically a replica of one that I hand forged, blade length, blade width, right down to the dimensions of the handle. I'd hand forged one, and the guard was a hidden tang knife. So the guard was made out of twin tower steel, and my organization auctioned that off a few years back. So it was one of my favorite designs. So design-wise, that's what this knife came out to be.
How come the length is, I'm sorry, how come the length is the length that it is? Why did you choose that?
So I used to carry a lot of the big knives, 6, 7, 8 inches. I thought I would need those down in different areas of the world in combat. And you really don't need that big of a knife. If you wear it strong side on your belt, if you're a lefty on this side, if you wear the knife mounted in the sheath that we have here, it could be mounted on your vest. A lot of guys carry the knife on their vest so they can draw it with either hand if you're wounded, much like a pistol could be worn. Length is a big deal. A big long knife, when you mount it on your hip, strong side or weak side, and you sit down in all matters of different vehicles, it's always jamming up and catching on the seat and riding up and jamming you in the side. And we'll talk about some of that stuff later also with handle design. But we settled on a knife that's a little over 5 inches, 5 1/4, something like that. Somewhere between 5 and 6 inches. 6 inches is a little too long for me. This length of blade here, right over 5 inches from top of the guard to the tip is a good length for wearing on the vest or on the hip.
How about the guard on it? Tell us why a combat knife needs a guard.
So, the knives that I hand forged, I found myself in situations carrying those knives, the knives that Bob made me, they all had guards. My mentor, Ed, once said, "I'll never make a knife without a guard." I kind of took that motto and ran with it. By taking all those different knives, I would take 4 or 5 knives per trip across, to combat, and I would test them out in different, real life situations. The guard is indispensable in keeping your hands safe, as you'll see in some of the videos that we've done. Anytime you need to stab, whether it's reverse grip or a standard grip, chopping, anything you need to do, if you need to choke up on the knife, you need a good guard there to protect your hand. If your handle is bloody, wet, slippery, grease, oil, gas, whatever's on it, and it doesn't have a guard like a dagger would, and you stab something or chop something and your hand slides over that guard, you're going to be in more trouble than you want.
So, but you don't want a knife with finger grooves in it, with many finger grooves.
Right. So as you'll see, as we're talking through the knife, we'll talk about some of the stuff on the blade, reference the finger grooves. A lot of the guys want to put the grooves on top. You can cut better, but it ends up just chewing your thumb up when you start doing cutting chores. This knife, all the spine area and the ricasso area is rounded, so it's nice and smooth. There's no sharp edges on this knife. The finger grooves in the knife really just inhibit the different methods that you can grab the knife. So I can choke up on this knife and not have to worry about where my second, third, and fourth fingers are in relation to the handle. I can really choke up on it, make a large knife a small knife for fine work, such as skin and game, if you so choose. So, all that stuff, reference, the grip and that, it really comes into play with keeping this knife in your hand, the design of this handle, all the contouring that we've done here on the spine, the double palm swells, and then all the swells underneath, all the cutaways, everything's round and smooth, the flared end here, all that helps grip the knife in your hand. You don't need finger grooves if you design the handle properly.
Now, how about the ricasso? Now, that's a large ricasso.
It is.
And one of the things I remember when we were going through the design of it, that you didn't want a scallop there, that you wanted it flat. Why is that?
Yes. So in this blade here in the ricasso, it's left unsharpened purposely up to about right here. Reason that is, like I said before, so you can put a full grip up in there and choke up on the knife. So you can use that knife in different situations and not worry about getting cut. A lot of your knives have a choil area right here, coil, choil, however you want to pronounce it, that could get hung up. You know, if you had to stab with this knife, that big divoted area could get hung up on any type of material, cartilage, anything closed.
A bone.
A bone, it could hang up on that and you're not going to be able to withdraw it. And also in just common chopping and cutting techniques, it's wasted space. Mm-hmm. And it also causes a stress riser in the knife. So a lot of knives that I've tested, that I've bought off the market, tested them, chop, cut, 90-degree bend. If you got a deep recess there in that area, they'll break right there.
Gotcha.
Because it's a weak area. So as you see in the knife that we've designed, it goes straight from unsharpened ricasso all the way into sharpened blade.
Gotcha.
Yes.
Lou, tell us why you chose Sheath 10 for the handle.
That's a good question, Bill. So, back through the 40s, 50s, 60s, up until today, looking back over the history of knife making, a lot of your handles started out as natural materials, whether that's wood, bone, antler, whatever that was. And they look great. And most of the time they function really well. There's some super hard materials out there that are natural, such as some of the sheep horn that's out there. It's super hard. For us, for this application, we chose the G10 because it's easily machinable for us. And it's super strong. And we can get all the contouring that we want in the knife, all that custom work that I would do by hand.
Yep.
We've put that in this blade. Or in this handle. Everything's been rounded, and everything just feels good in the hand. Palm swells on each side, undercut here, widened in the butt, and it's just really strong material. Blood, water, oil, sand on it. Any type of media, I've tested on the G10, and you always have a good grip, whether you have gloves or you have just your bare skin. So it's just a great, super hard material.
One of the things I want to point out is we cut this handle out of solid G10. It's not injection molded or anything like that. And you'll notice, like Lou pointed out, the hand swell, all the different curves, how nicely blended this is. We designed this to fit a medium to large man's hand.
Correct.
And to fit it ergonomically. And the way we get that is we go and we 3D machine this with a small ball end mill. In other words, we don't take an end mill and buzz around it and just put a chamfer around it. All those features right there are from a little 1/4-inch end mill going back and forth, back and forth, back and forth on one of our mold machines. We have milling machines that have a very high-end processor that can handle this going back and forth in those small lines. So each one of these handles is done like that. They're not injection molded.
Sure. And also you get a as we'll talk about with the Sheath later, you get a nice fit for either a right-handed user or a left-handed user. I hate to use the term, it's a true ambidextrous knife, but in this case, I think that's what we've ended up with. It feels just as good in the right hand as it does in the left hand. It points naturally right down the arm. A lot of knives, they're the blocky style handles you see. It's just like holding a 1911.
Yep.
It points really nice, and then you put something that's not as nice in your hand, and you can't even see the sights.
There you go.
Until you move the gun around. So similar to that, you grab a knife that's not really set up like this one is, and you're basically holding it sideways. The blockiness of it forces the knife to turn your hand. So what we've done here is with this, you can chop very naturally, you can cut naturally, as we'll show later, and it's just a great handle.
Let's talk about the glass breaker. When we were first doing the design of it, I know that I had put a big pointy type of screwdriver type thing on there, and you said that was an absolute no-go. Why is that?
Well, as we talked about earlier, this is a tool, but first and foremost, it's a cutting tool. So, you know, for me, when we first discussed it, you know, if I wanted a screwdriver, I'm going to reach for my Leatherman. So, and you know, the main reason on this knife is the way, how you're going to use it. So why you wouldn't want those pointy edges if you wore it mounted on your vest. In this configuration, you know, a MOLLE attachment, an assault vest, a backpacking vest, or a backpack that has all the MOLLE on it on the straps, something like that. And you start moving around, you take a fall, you take a spill, it's going to be close to your face.
Or you bounce up in the vehicle or something like that.
If you're riding in a vehicle or a helicopter operation, you know, military use. If you get in a tussle for law enforcement guys, if they want to wear it on their kit, SWAT teams, you know, first responder teams, whatever, and you're out working in the dark, you know, it's dark and scary. You don't want your equipment to injure you. You see how close that is. If you took a spill, it could cut you there. So what we designed into this, you know, I think works great as the test videos show. This glass break here on the end here, it protrudes, you know, approximately right under 1/4 inch from the back of the G10. And so glass break wise, does it have civilian reasons for that? Sure. If you had to pull, you know, you have a wreck on the interstate and you had to pull your child out of a vehicle and the doors are all jammed up and you had this with you, you could break the glass if you know what you're doing. And military law enforcement, you got to have it. When you have to extract people from a vehicle, you don't want to carry a bunch of heavy tools, breaching tools with you. This plays a big factor in keeping yourself light.
Gotcha.
So, yeah.
You know, at SHOT Show, I think it was either 2004 or 2006, Bob Dozer was there. I think he was at the K-Bar booth, and he was signing a little folder. He'd sign it with a custom message there. And I asked him about knife materials and things like that, and specifically I asked about L6, which is a favorite steel of mine. And he's a true gentleman, and he actually took about 10 minutes to talk to me about knife steels, about L6. I remember he told me, he's like, it's a great steel, but it'll rust before it gets out of the shop. And he said, well, he asked me, he said, why would you consider a knife with L6? And I said, well, you know, it has some ductility to it at the higher hardnesses. And he said, you know, a knife is a cutting tool, just like you said, Lou. He says, if you need to pry something, use a pry bar. But as a special operations soldier, sometimes it's not just a cutting tool. There's other things that you have to do with it.
Most definitely.
Like what?
Well, like we demonstrated the video earlier, you know, first and foremost, a cutting tool. But if I want to pry with it, I want to be able to pry with it. So how does that happen? You know, we differentially hardened it. So we've got the, you know, the difference in the Rockwells. You got the approximately 33 on the spine in the center, and then down to 59 on the cutting edge, or up to, you know, hardness on the cutting edge. It just makes it very ductile as far as the human hand can't put enough force on this knife, as we'll show later, to actually bend the knife. So it makes it, in extremist times, you can pry with it. So, you know.
Like a glove compartment,
a
filing cabinet, things like that.
You can open, and all this I've done, and we've also done some of that in the video of the demonstration. Military law enforcement, you're having to search somebody's vehicle. You're overseas in the military, and you got to search a home after it's been, you know, been cleared. You know, you don't have to carry a bunch of tools with you all the time. You could use this. What we've done in the car, we've pried, you know, the glove boxes that were locked. We've pried the trunks open just enough to where we could, you know, break the locking mechanism free. We cut the carpet out of it. We've pried the door panels off to search inside there. And you know, a lot of times, as we illustrated in the demonstrations, you know, you want to pry just enough that you can get something else in there. You know, two guys' hands and help assist it. You always want to try to protect that cutting edge. So I'm always trying to leverage, when I'm prying with it, the spine. I'm always trying to protect how I'm putting the knife into something to pry with, as we also showed in the video.
Gotcha.
Protect the cutting edge, but it can be used in extremist times.
Now, a lot of the steel that you use in your custom knives is 52-100, correct?
That's correct, 52-100.
So when Lou was talking to me about how the special operation soldiers use their knives, you know, I was trying to decide on what steel to use. And if you want to be able to have that knife have some sort of ductility and at the same time hardness on the cutting edge, it basically ruled out what I thought were stainless steels that did not have that combination. So I looked at other steels, for instance L6, it's a very good steel. But I wanted something that was cutting edge. And right down the road from us here in Reading, Pennsylvania, there's a steel company called Carpenter Steel. They're 128 years old. They're a specialty steel company. In other words, they don't make I-beams and flat plates and angle iron and things like that. They make high-end tool steels, steels that are used for medical implants, steels that are used to form other pieces of metal when they're hot, like a forging steel. They got their start making armor steel that's used for naval cannon shells that'll pierce through armor back in the late 1800s. And they make a lot of specialty steels. And as I went through their selection of steels, one stood out to me, and that was PD1. And as I discussed this steel with Lou, it really sounded like it had a good combination of some ductility at the higher hardnesses. When you have a knife blade, you really want that edge to be a minimum of 59. Sometimes you want it to get up into the low 60s. 60 Rockwell is your ductile to brittle transition point, where above 60, that steel is always going to fail by snapping. It's going to be a brittle fracture. Below 60, there'll start to be some sort of ductile failure there. But like you were telling me, like sometimes what you do all day is you work with your explosive charges and you're cutting cardboard.
Sure.
Right? Yep. And cardboard is notoriously very, very bad on a knife edge. You know, I have some knives that I cut boxes here in the shop, and it's not, I cut 3 or 4 boxes and the thing is dull and needs to be sharpened again. So you want a knife that's going to stay sharp. But then you do that during the daytime, you cut your charges during the daytime and you're cutting up cardboard. Now you're going to have to pry with it at nighttime. So we wanted a combination. So this Carpenter PD1 seemed to have everything. Now, PD1 stands for punch die 1. Carpenter has this naming convention with their steels, and it's a very unique naming convention. But punch die 1, it refers to that it's a cold work tool steel. So we know these guys at Carpenter. Like I said, they're 45 minutes up the road, and since they go back so long, they've been involved a lot in toolmaker apprenticeships back in around World War II. These guys wrote the book on when young toolmakers started to learn about working with tool steel. Carpenter Steel wrote this book, Tool Steel Simplified. And it's a great book. You can find this on abe.com. It's only a couple bucks. Very, very much available. Anybody who went to a technical school to learn tool and die making or machine shop, this was like a textbook. And, you know, I'm looking at this PD1. I had to ask them what it meant. They don't tell you. And one of the things I noticed about these guys is they have this way of naming steels. Now, I'm going to turn to page 114 here, and I'm just going to go through some of these steels that these guys make, okay? The names here. Number 11 Special, Solar, KW, Stentor, RDS. That's my favorite. That's L6, okay? And the question is, well, what does RDS stand for? I'll get back to that in a minute. Hampton, number 484. Vega, number 610. Star Zenith. So these guys have these wild names. So we were up there, we were talking steels, we were talking PD1, and I said to these guys, and they're steelmen, okay, they're not machinists. These guys are metallurgists, underneath the umbrella of steelmen. This is what these guys do. And I said, how do you guys come up with these names? I said, you probably after work, you go down to the corner bar and you know, drink Yingling beer and eat pierogies and concoct this stuff and probably don't need the good names come to you after like 2 or 3 beers, right? And he's like, they're like, Bill, you nailed it on the head. That's exactly what happens. We go down to Mike's down at the corner, you know? We go down there and have a couple beers after work. And we started talking these names. And I said, well, what does RDS mean? And they're like, it means Reading Double Special. Well, Carpenter Steel is in Reading, Pennsylvania. And I said, man, that's pretty cool. And then they said to me, and they had a little grin on their face, they said, guess what A cube means? I'm like, A cube? I don't know. And they said, alternative to copper beryllium. And they all started laughing and started high-fiving themselves across the table. Okay, so this is their thing. So PD1, when you think of it, it has a meaning. Punch die 1, cold work tool steel. Now, with PD1, it's a very complicated heat treatment. And we don't do the heat treatment here. We do it at a good friend of mine's, just up the road a little bit, in Trumbowersville. PD1 has to be triple tempered. That's what it has to happen. So I'll go into a little bit of the technical details about it. Once we take the knife blank and we cut it out, we machine all around the edges, all right, to get the edges true. And then we grind it flat, and then we send it out, and we harden this to approximately 30 Rockwell, and it gets triple tempered. At that point, it then gets induction hardened right around the edges. And this is a technique that Lou uses right here in his custom knives. You go through a lot of effort to have the spine of your knife softer than the edge, correct?
Correct. And it's all done by hand, you know, with acetylene torches and very, you know, done multiple times, you know, at least 3 times. Yeah, and it's very time consuming, but it works, you know, as you'll see in the testing.
So we have an automated way to do this, okay? It uses electrical induction to just harden this edge right here. Then it goes back and gets tempered 3 more times, okay? So this is a total of 6 tempers, vacuum tempers on the steel, and what you have is this knife is approximately 30 to 35 Rockwell or so, except for a little over 1/4 inch of this area right here, right where it matters. It's a very complicated type of heat treatment. Now you also notice the finish of this. This finish is done by a sister company of ours. It's called NCC, Nano Composite Coatings. This finish is called Nano Weapon. It's an amorphous DLC coating. It's extremely hard, and Lou likes it because it's dark and it's matte, it's not shiny, and it's very hard, very abrasive resistance, and it doesn't harm the steel, and it's not put on at a high temperature. You'll be hearing a lot more about Nano Weapon as Geissele gets some of its parts, like a bolt carrier group coating going with this material, but that's the coating that you see on there. It's not your standard PVD type coating.
So we'll go ahead and, so the knife, when you folks get it, will come packaged with this on there.
Yep, that's right.
Covering the coating edge, a protective, for the folks that like to have the safe clean, this will protect the edge in packaging, and you know, they can be assured that their cutting edge has been protected the whole time. So let's give that a little bit of go juice there.
Now, one of the questions, and something I've always been disappointed in a lot of knives, is the sheath. A lot of knives, a lot of high-end knives, they don't come with a sheath. So the question is, what kind of a sheath were we going to do with this? So the Geissele engineering team, you know, we work with metal. That's our specialty. Machine metal, not stamp metal, okay? Not plastic, not leather. We decided to make a sheath completely out of aluminum. And with Lou's guidance, we came up with this guy right here. And Lou, if you want to just show how that guy works.
Sure. So what are some features, you know, do you want in a sheath? And that's what we talked about. I want to be able to mount it in multiple ways. So this sheath here has the MOLLE attachment on it that all your backpacks today are coming with, all your assault vests for SWAT teams, all your military vests. That system was invented years ago, so you can mount it upright, you can mount it on the back of your pack. This will also come with a belt attachment, so you have multiple attachment points. You'll see the other holes in the slats here, so that's kind of like an old school thing, from being back and having to tie everything down with 550 cord before all these fancy attachments came about in the military. So for the guy that wants to double tie it down, or he's just not comfortable with, he wants to mount it horizontally, you got all these tie down points for paracord, zip ties through the holes, a whole plethora of tie downs. So that's just, there's nothing out there that's like that. Usually you get stuck with one mounting system or the other. Some of the other great features, you got the locking mechanism here, which is like, to me, number one. It's going to keep the knife in the sheath. So it's in there. It's not coming out till you want it.
Till you press the button.
Till you press it and pull up on it.
And it's ambidextrous too. You can put it in the other way, right?
So you have the locking divot on the other side. So now you have a true left-handed knife. If I'm left-handed, if I'm right-handed, I'm good to go either way. And it's very hard for the lefties out there to find knives and sheaths that actually fit them.
Yep.
So a lot of time I make my own. So knives that I've bought in the past, I just make my own left-handed sheath and wear my knife vertical. So this kind of solves that problem for the left-handed folks out there. Just a super efficient, great all-around sheath. The locking mechanism, if you're going to be conducting military operations, military free fall, static line parachuting, underwater diving, rolls right over to the civilian application for diving. It's protected by the coating, salt water. It's not going to harm the steel. It's not going to corrode. If you notice, as in this blade that we've bent here, the whole blade is covered, all the way back through the tang. So the steel is completely coated. But this locking mechanism really, you're not going to lose your knife. Mm-hmm. If you want to wear it on your pack, so you're trudging through the jungle, you're out west, you're hiking, you're in Europe, whatever, wherever, multiple applications, military or civilian, when you get to where you're going and you take your pack off at the end of the day, the knife's still going to be there. Gotcha. It's not going to be yanked out by a vine somewhere in the jungle. So,
let me show you a little bit how we make it here. This is the top cover. And if you look at this guy here, you'll see all the machining marks in there. This is made from this block of 7075 T6 aluminum. Extensively machined to be very lightweight. All the bevels here where your knife goes in, it guides the knife in. All your little features for your latch. This is the backing plate right here. You'll notice this threaded in area right here. I'll get to that in a minute. I'll show you what that's about. Here are all the little hardware pieces. They're all made right here in the Geissele shop. You'll notice the screws here for the handle. They're custom machined torque screws, custom designed, custom machined with a little milling machine to cut that Torx head in there. This little guy here is the tensioning button, made out of 17-4 stainless steel. It's all going to be nitrided. One thing that we wanted to do with the sheath was make it completely universal. So it does lock, but at sometimes you don't want it to lock. You want to be able to pull this thing out without hitting it. So what we have different pathways to suit every type of situation. This one here is an automatic locking sheath. This is the first generation. The second generation, which I don't have in front of us right now, when you push this down, this will stay up and it will now not lock until you push this down. If you don't want it to do that and you want the automatic locking, we're going to have a provision by these small detent adjusters here to remove that. So if you want automatic locking, you can have it. If you want to be able to pull this and then put it down into the sheath without it locking so that you can pull it like this, purely by tension, you'll be able to do that. If you don't want any chance of it locking in, we're going to provide another locking button where that doesn't happen. It will not lock. And this tensioning button in the back, there's a nylon foot that goes in the back here, and what that's going to do, that's going to provide tension through this tension button and a stack of Belleville washers in order to tension the blade so you can get as much tension as you want, whether you want it light, whether you want it heavy. You can choose exactly what you want. And we're also going to come out with a very nice Kydex sheath for this guy. It's going to be in Cryptek colors. Lou has a friend Josh
Wilder.
and he's going to make this sheath for it. He's a master sheath maker. It's going to be beautiful. I don't have one here to show you, but that's going to also be an option on this knife. So we've tried to make, Lou and I have tried to make this knife to be as universally accepted for a combat soldier. That's our design. It's not a beautiful knife, as in it's not artistic where there's artistry to it. This is a very, very functional tool for a very, very specific application. And I know from the Abraham and Moses team and the Geissele engineering team, we could not have done it without Lou Goodman and his expertise and experiences here. So Lou, I want to thank you for all your help with everything, and look forward to this knife. We look forward to bringing it to market and bringing it to you. Thank you.
Thanks.